Welcome to problems that are specific to multiplication. We'll have some applications of multiplication later on, but in this video, I'm going to look at a few practice or example problems for you from 1.3. So, multiplication. Multiplication is essentially repeated addition. So, I have my textbook here, and I have your key, answer key, your solution guide. So, I'm only going to do the even problems, which you don't have solutions to. You have solutions to the odd problems as a resource. Again, do your best when you do these problems, the odd problems that are assigned, and I will do what I can. I'll do what I can to provide you with as many examples as you need, and I will use the even problems. So we look at number 2. Actually, let's look at number 2 because this is number 3. But if we're looking at number 2, the question is, what is 3 times 4 if you're going to put it in a number line? So we're going to look at the system they use. If you're looking at 3 times 4, 3 times 4 would be, one way you could write that is 4 plus 4 plus 4. So that's 4 3 times. And so when it's 4 3 times, we can go on a number line and go from 0 to 4. And then from 4 to 8, and from 8 to 12. So just depicting it from a number line, that is one way that you can show your work for the problem. So you would be doing number 1 from this section, and you can show your work. Okay, let's go on to another example from a different section. Let's look at number 6. Now, in this section, you learned about different properties of multiplication. We have the associative property of multiplication, just like we have the commutative property of addition. So we have the associative property, we have the commutative property, and we have the identity property of multiplication as well. So notice that multiplication and division, we have certain properties of real numbers that we use in doing these problems. So let's go ahead and look at the number 6. 5 times 8 is equal to 8 times 5. Let's just call these CP and AP. So this will be the commutative property of multiplication because you've moved the location of the 5 to where the 8 is and the 8 to where the 5 is. So you have rearranged them, and that's going to be equivalent. So that's the commutative property of multiplication. Number 8, we'll just look at a few of these. The next problem is asking, how about 4 times 6 times 5? And if we have the parentheses that way, is equal to 4 times 6 times 5. Now, the parentheses has shifted. So the numbers remained where they were. 4, 6, 5, 4, 6, 5. But the parentheses shifted. So that's the associative property of multiplication. How about number 10? 8 times 7 is equal to 7 times 8. What do you think about this one? The numbers moved around. The commutative property of multiplication. Number 12. When you have 8 times 6 times 4 is equal to 8 times 6 times 4. Did the numbers move? No. That means we use the associative property of multiplication. And then finally, we'll look at 14 and 16. Number 14, what do you do when they ask you 39 times 1? For number 14, we are looking at one of the properties I mentioned earlier. I wrote it in the form of just calling it the identity property of multiplication. So with this one, for number 14, we have 39 times 1 is 39, and for number 16, 44 times 1 is 44. Both cases are dealing with the identity property. Your book mentions it slightly differently. They say the multiplicative identity property, or I say the identity property of multiplication. The multiplicative identity property, that's fine. You can use that for this section. So we've looked at a few practice problems. We're going to go down now, and we're going to look at the next section, which simply, this is from number 17 to 28, and it has to do with multiplying numbers. Now, here's the thing. If you went through whatever textbook you went through from elementary school all the way to pre-algebra as a course, which is usually offered in 5th, 6th, 7th grade or 7th grade, you would have multiplied things like 700 and, or actually 907 times 6, which is number 19. You would have done these types of multiplication where you set it up like that and you multiply through. So please, I recommend that you just do the problems that are assigned from that section by using the skills that you've learned for multiplying. And that's actually the same for number 29 to 40. You're just multiplying using the principle where you multiply 6 times 7, you have 42, you put a 4 up there. 6 times 0 is 0, you bring, and then you have the 4. 6 times 9 is 54, so you have 5442. So just use your skills of multiplication, and that is what you would need for those problems. For number 41 to 44, you're dealing with a set of arrays and you're counting how many arrays are, or how many boxes exist or objects exist within those arrays. You can just check whenever someone gives you a certain number of things. So if I give you this, so if someone gives you this, you can take these values and you say there's 4 of them, and then you can count down and you can say there's 5 of them. So you literally just say 4 times 5, and that will give you what you need for the circle or the shapes I drew here. Instead of counting them one by one, I can just use that principle if it's just a well laid out shape, in a well laid out shape like a rectangle. So basically like finding the area, which leads us to the next section where we give you the length and the width. So from number 45 to 52, we give you the length and the width. Can you find the area? Can you find the perimeter? So let's do both of those. Let's pick out some problems. Number 46. So this should help you with number 46 to 52. Again, the idea is that you watch these videos, get some examples that you can use to then do the problems that have been assigned. Number 46. The length is 48 inches and the width is 24 inches. I recommend that you practice, use this as a warm-up for your multiplication, 48 times 24, and the rest you can follow the steps from your multiplication skills. So that's what you would do for number 46, because the formula for area is length times width. So because the formula is length times width, you can use the formula of 48 times 24. How about if I told you to find the perimeter of this same shape, which would be the same type of problems you'll be doing in the next section? What you do is you have 2 times length plus width. That's one way to look at it. So you could just say 2 times 48 plus 24. You add those two numbers together, you multiply by 2, and that is the perimeter of the shape. The next section, they give you a few things to look into. They say a set of beads costs 50 cents per dozen. What is the cost of 19 dozen sets of beads? Let's go back. That's 53, so you're doing that one because you have the odd problem. But let me look at number 54. A set of beads costs 60 cents per dozen. So they've told us they cost 60 cents per dozen. Okay? For each dozen, they cost 60 cents. Now the question is saying, what is the cost in dollars of 7 dozen? So now you're looking for 7 dozen. So imagine if it's 60 again for 1. For 7, we will then multiply the 60 times 7. So 7 times 60, so we get 420 cents or $4.20. Okay? So what do we do with these ones? We read the question, we understand what they're telling us, and we apply reasoning to the question. We apply reason. So we look at the fact that there's 60 cents per dozen, and there's now somebody comes and says, I want to buy 7 dozen. Well, you take that 60 cents, you do it again, you do it again, you do it again. So 7 times. That's how we get number 54. Number 56, if a math tutor worked for 46 hours and was paid $11 each hour, and that's pretty good pay for a math tutor that maybe, for example, might be working in a math lab at a university. I remember I used to do that as a student, and they pay about $11 an hour. And this tutor 1 week decides, I'm working 46 hours. I'm going to work hard. how much is this tutor going to get at the end of the day for that particular week of working hard? Forget about the taxes for a second, which of course is the tax details that we can look into, but just how much. You take 46, you multiply it by 11, and that's how we do number 56. So you have 46 hours, and each hour is $11. So you multiply that by 46 hours, and that will give you the answer that you need. Number 58, there are 12 eggs in 1 dozen and 12 dozen in 1 gross. How many eggs are in a shipment of 11 gross? So you have 12 eggs in a dozen, right? So you have 12 in 1 dozen and 12 dozen in 1 gross. So now they're saying in a shipment of 11 gross. Well, we have to multiply that by 12. And then we have to multiply that by 12 again. And that will take us to our destination. Very good. Okay, let's look at the next section of problems. Number 62. Which of the following 4 expressions differs from the remaining, or is different from the remaining 3? So let's look at some practice problems here. Number 62. So we know 12 over 2 is 12 divided by 2. 12 divided by 2 is clearly 12 divided by 2. And 2 goes into 12. That is also okay. But 2 divided by 12 is not the same thing as 12 divided by 2. All these other ones are saying 12 divided by 2. This last one is not. It's saying 2 divided by 12, and that is not true. Remember the commutative property of multiplication? It works for multiplication, and it also works. There's a commutative property of addition. But there's no property of division that allows you to change the numerator and the denominator. They're not interchangeable. So that's very important to keep in mind. Number 64. So the question is basically asking, which of the following representations of division is different from all the other ones? So for number 64, you have 8 divided by 4, 8 divided by 2, 8 divided by 4, 8 divided by 4, written like that. You have 4 goes into 8 like that. And then the last one is 8 goes into 4. Well, again, 8 divided by 4 is the same thing as 8 divided by 4. 4 is going into 8 here, that's fine. But this is the opposite, and that is not valid. So that's number 64. Number 66. We have 9 goes into 54. That's straightforward. That's 9 goes into 54 6 times. 54 goes into 9. So right away, red flag, we know one of these is not true, right? And then 54 over 9, right? That's the same thing as 54 divided by 9. And 54 divided by 9. This and this, we know. Same thing. And that brings us back to that one as well. Same thing. So that leaves this one out. Again, division is not interchangeable. So I hope you see what they're looking for in this section. In the final section, or in the next section, sorry, it says in exercises 69 to 82, simplify the given expression. If the answer doesn't exist or is undefined, write undefined. So when you have 0 divided by 5, for example, in number 70, we know that the answer is just 0, right? I apologize, the PowerPoint will come back on here in 1 second. So when you have 0 divided by 5, it's just 0. When you have number 72, which we'll come back to, but this is number 70. So we have 0 divided by 5, which is just 0. 0 divided by anything is 0. Because if it's 0 divided by something, that thing cannot go into 0. 72 though, it says 24 divided by 0. In mathematics, the word we use for most of your classes, you hear the word undefined. So that is undefined. You just say undefined and you're done. That's number 72. Number 74, we have 20 times 0, which would be 0. Anything times 0 is 0. Number 76, we have the same problem again of undefined. 23 divided by 0, and that's undefined. For number 78, we have 25 on the outside, 0 on the inside. So you have your divisor and your dividend Same thing as writing 0 divided by 25 or 0 over 25. And that's 0. So those are some examples for you to keep in mind. Now, let's look at number 81. That's an interesting one. It's the same idea, but it just looks interesting. 0 divided by 0 is also undefined. There's more technical term we use for it, but we'll just leave that there for now. So we've looked at examples of situations where you can't divide by 0, but you can have 0 divided by something. So let's pull up the next set of problems. The next set of problems from number 83 to number 106 have to do with, basically you're using either long division or you're using division principles to do those problems. So let's look at the next one. We're not going to do the ones from 83 to 106 because those are just using your principles of division, long division, and depending on where you're at and your skill, accuracy and speed with multiplication and division, maybe you can do 5 of those problems, 5 from each section, and then you can use a calculator later on. I'm really cautious when it comes, I take a lot of caution when it comes to using calculators. I want students to be confident with number understanding, so that's very important. So if you're, let's talk before you really get into using calculators. Number 108. So before 108, we have a concrete sidewalk for 107. It's on the same thing with number 8. A concrete sidewalk is laid in square blocks that measure 5 feet on each side. So if you have 5 feet on each side, concrete sidewalk is laid in square blocks that measure 5 feet on each side. How many blocks will there be in a walk that is 180 feet long? So if you have 180 feet long, and I have 5 increments of 5, what do you think will happen? Well, if it's 180, you take 180, you divide it by 5. And that will tell you how many of those you would need for a sidewalk that is that long. 109 in your textbook, one boat, 109, a boat to an island, so I'll take 110. One boat to the island can take 4 people. How many trips will the boat have to take in order to ferry 46 people to the island? Well, basically, think about it this way. The boat goes and it takes 4 people. It comes back and it takes 4 people. So 46 divided by 4 will be one way to look at it. But 4 is not 46. 4 does not go into 46 an even number of times. So think about this. How about 44 divided by 4? Well, that's 11. But you would still have 2 people waiting. So you have to do a 12th trip. So basically you have to just plan for 12 trips. Because the 12th trip will take care of these 2 people. You cannot take everybody in 11 trips. But a 12th trip will bring the remaining people that you don't have. So that's how we do that problem, and that's number 110. Let's look at number 112. For number 112, we basically have, if street lights are placed at most 70 feet apart, how many street lights would be needed for a street that is 3 miles long? Assuming there are lights at each end of the street. So you know that 1 mile is 5,280 feet. And you're dealing with, if street lights are placed 70 feet apart, and it's a 3 mile stretch, we know that 5,280 feet in a mile, so we multiply that by 3. The answer we get, and I can tell you that we take that answer and we use it, we divide by 70, and that will tell us how many street lights we need for that particular stretch. In number 111, you'll be doing a similar problem. You do the same thing. You multiply the number of miles by the feet. You convert the miles to feet, and then you divide by the miles, the feet apart that you want to do. Something to keep in mind for number 112. 114, a concrete sidewalk is laid in square blocks that measure 5 feet on each side. How many blocks will there be in a walk that is 445 feet long? Again, you take each one of those, you have each is 5 feet, 5 feet, 5 feet, and you have 445. So you're basically dividing the 445 feet by 5 feet on each side. That's something that you can do for that question. I'll finish up with a few more word problems and then we'll be done with this section. So all these problems generally have to do with understanding something they're trying to explain or teach you. You know, whether you're dealing with a multiplication dimension to it or you're dealing with a division dimension to it. It's everyday. Some of these are everyday problems because math deals with everyday problems. You look at this and you see, how can I apply my understanding of multiplication or division to this problem? Let's try 122. A conventional refrigerator will run about 12 hours each day, and it can use 150 watts of power each hour. How many watts of power will a refrigerator use over the day? So if it's 12 hours each day and it's 150 watts of power each hour, so you take 150 watts of power and you multiply that by 12 hours, and that will tell you how many watts of power you need. Number 126. The mayor of Providence, Rhode Island wants to tax its 25,000 Brown University students $150 each to contribute to tax receipts, saying students should pay for the resource they use just like the town residents. How many dollars would the mayor generate? So you take $150 from each student and you multiply it by 25,000 students. That's a lot of students, by the way. But of course, Brown University is pretty popular. But if you want to tax all the students, then that's what you would do. And then finally, number 130, an average bale of hay weighs about 60 pounds. If a horse eats 12 pounds of hay a day, how many days will one bale feed a horse? You have 60 pounds, and you basically divide that by 12 pounds per day. So it would take 5 days for the horse to eat the hay, the bale of hay. I hope this was helpful as you do your assignment for 1.3. You know, read the questions, understand what they're looking for, and then give your best. Have a great day. Thank you.